about this time in our study of radians, you might be asking, why are we studying radians anyway? Why can't we just use degrees? That seems like a perfectly useful measure of angles. Why complicate matters with all these fractions of pi and all this sort of thing? Well, that's a very good question, so let me try to answer this. So first of all, I want to call your attention that let's say we want to move from point A here at 0 degrees to point B over here. Well, there's two ways of getting from point A to point B. One would be to rotate a certain angle. And we could call this then an angular measurement. So an angular measurement tells how much of an angle we rotate. The other thing we could do is we could look at rotating from point A to point B as traveling along the outside edge of the circle. So we could go from point A to point B by traveling along part of the circumference of the circle. And this is a linear measurement. As we see up here, and I guess I'll go ahead and put this down as my starting point. As we see up here, angular measurements can be measured in degrees or radians, and they measure the amount of rotation in an angle. Linear measurements, which could be inches, feet, miles, centimeters, meters, all kinds of other linear type measurements, measure a distance from one point to another, which is also called a displacement. Notice that the linear measurement is called linear even though we are not moving in a straight line. So this is a linear measurement. Now, what is so special about radians? Well, we know that the radian measurement was defined by saying that 1 radian angle cuts out an arc that's equal to the radius of the circle. So that leads us to our big ideas. An angular measurement in radians has a direct relationship to a corresponding linear measurement. 1 radian angle corresponds to 1 radius length. This is not true for degrees. So recall what we did earlier when we first introduced radians. We said if we take this radius length and we take that same distance along the outside edge of a circle, this was a 1 radian angle. I'll write it as 1 radian. So we have a 1-to-1 correspondence to a certain linear distance and 1 radian angle. Something else that's interesting about radians is that they have no unit. So when we say 1 radian, we technically are just saying 1. Now, I'm going to still write radian because it helps me to make sure I'm understanding what I'm talking about. But we're going to see this in our next example when we look at how radians are applied to a physical relationship between linear and angular motion in physics. That should have an S on it, so let me add the S. Okay. We can't use degrees because degrees don't have this 1-to-1 relationship between linear and angular measurement, and degrees have units that don't make sense in the context of the problem. So we'll see that in our next example.